private Behlendorf. I'm the ZFS project lead for my national laboratory. All right. What I wanted to talk about a little bit was basically a status update for how things go on Linux. So the current version is 0.6.3. So because on the Linux side we're making ZFS out of the tree, we've had the version releases so we know what the heck people are installing. The current version we're at is 0.6.3. Was released in June 12th. We've got packages out of free for a lot of distributions these days, so they can be easy to install. All the major distributions you can see up there, plus a lot of smaller distributions. I don't want to say that these are the only ones that are supported, but there are lots of smaller ones. I just learned about another one the other day. I don't know if you guys heard of the distribution called Mixos. One of my coworkers was installing it on their desktop, and actually they had built-in ZFS support for the installer. I thought that was pretty cool. But lots of people are doing stuff with it, and at least me. We got a huge enthusiastic user community at this point. We've been around for a while with a very active discussion list that sees a lot of traffic. So that's mainly user focused. There's a reactive IoT channel, and a free node, and of course the website. So what's in 0.6.3? So it's a stable release that's out there now. It's pretty close to near feature parity, I would say. The other OpenZFS implementation out there. And we've been systematically trying to address the functionality that's not there. So as you can see, it got some of the fairly recent changes. The updated bright file code is in place in there. We made some ARC performance improvements. And then a lot of the other changes here are in fact Linux-specific things, because Linux is different, fairly different than a lot of the other platforms. A lot of our effort goes into just the integration with Linux and how Linux does things to make things work well. So things like POSIX tactics, right? I mean, we don't support ZFS tactics on Linux, and all the utilities expect POSIX tactics. So POSIX tactics need to work well. A lot of these things fall in that category. SE Linux, obviously Linux thing. Systemd, obviously Linux thing as well. So a lot of our work is on that side. We've also got a wide spectrum of users on Linux. We've got people who use it on everything from their desktop to supercomputers to whatever else you can think of. Lots of people trying to do interesting things with it. We also have a really diverse set of hardware on the Linux side, I would say. Like I say, we run it at Livermore on supercomputers, basically, for our parallel file systems. So we run it on 686, 64 systems with lots of cores, lots of memory. That's kind of our focus. I run it on my desktop, which works really, really well. It's nice to have it as a file system. I've also heard recently of someone, I think it's in the track with someone filed this issue. They had actually taken Cyanogen mod for their phone, and they had rebuilt ZFS for their phone, right? Which I thought was pretty cool. I think it was like a Samsung S3 or something like that. The fact that that's even possible, I thought was pretty cool. So yeah, it's got support for ARM, all that good stuff. We've got a lot of developers that are contributing. I think this is pretty encouraging. We have 58 different developers for the last release. I was surprised by that when I went back and looked at commit logs, but it's great to see lots and lots of people contributing patches and all the code's out there, and it's going to make it really easy for people to do the changes. So going forward, our next release is going to be 0.6.4. Frankly, it's going to be more of the same at this point. Keep pulling in new OpenZFS features, keep fixing gaps in the code, continue to improve the Linux integration. As you can see up there, basically it's pulling a lot of stuff that came from Illumos and other platforms. All the feature flags, all the great work done by Delphix there. We'll be in the next tag. All that code's merged now in the branch. We're just letting it soak before we kind of tag it, make sure it's stable when everything works right. There's some functionality that should get filled in here on the Linux side. People have been wanting for a while. AIO support comes in. Richard Young did a really nice patch for that. AIO support. I'd like to get direct IO support in too, because I've recently learned that certain software packages on Linux, if they detect the IO support, they expect direct IO support to be there too. If it's not, it doesn't work so well. So those two might want to go at the same time. So that may need to happen. Most of this functionality, as you see, is already done and merged. Some of the things that aren't good this time around for us at school. We've got 37 different developers so far, and 22 commits. I think things are coming together nicely. We'll tag it when everything's done, stabilized, and so the other thing I wanted to address was a question I get asked a lot, which is what's between the Linux board and IoT or one of those cells. So up to this point, at least in my mind, we've kind of been in this 0.6 release window, which is functionality, integration, make sure everything's there, make sure it's right. Things work very well today, they're very stable, but like I say, there are some gaps that we're filling in, like the right LLNL. And then going forward, this should kind of be viewed as like a high-level roadmap to guide development. Nothing's strict here, right? Things can get finished in whatever release they're done in, but it kind of lays out the key things that I see that need to be done before the one release, or at least what I like to call through the one release. So all development's going to continue in parallel, and features and bug fixes will get merged and ready, but there's some basic focus for each of these tags going forward. So let me go through them real quick. So for the 07 release, I want to get the memory management control. So things work fine today on Linux, but we have some of the issues that the OSP was talking about. Things we want to fix. We want to get the page caching and ARC integrated, like all the other things possible. On Linux, the ZFS is pretty poor, right? So we really want to work with it as well as possible. So that means mapping the ARC buffers with the page cache, with memory reclaim from the right? There's a lot of benefits from properly integrated with Linux and not being on the side, like kind of kernel infrastructure like things are today. One of the nice things of integrated with the memory cache is we get accounting done right. So if you're not integrated with a page cache in Linux, things like memory accounting for containers isn't strictly handled right, or at least you need to handle it manually, which makes it a little more complicated. You get integrated with page cache, memory accounting is done for you basically. Memory reclaim on Linux, the ZFS, which we can't change on Linux, so we're out of tree, makes certain assumptions. It makes assumptions like page cache will always be reclaimed before cache objects. So we need to integrate into the page cache to make sure the ARC is dropped first before anything else is counted. We just play some tricks now to make that better, but it'll be way better if we're integrated with page cache. Fragmentation goes away if we're integrated with page cache, so we can allocate just as many pages as we need for buffers. As mentioned before, we do absolutely double cache or map at the moment on the Linux core. There will be a version of an ARC buffer, and then there will be a copy of pages made mapped into the address space. We really want to unify those two. And on the Linux side, we really can't properly support 32-bit platforms until we get this done, because Linux has a really small virtual address space for 32-bit systems, just a couple hundred megabytes. And if we get back, properly integrate the page cache, we don't have to use that virtual address space. So going forward, the big thrust I see here is kind of a mundane detail, but a really important thing. I think Matt alluded to something similar to this in his opening, which is this is kind of infrastructure, but it needs to be done right to make it easier for people to use the board. So this is consolidating the ZFS and the SPL. So the SPL for the Linux board is a reporting layer. Basically, it implements those core Solaris features or functionality that we need, right? Those APIs. So we'd like to merge those. Right now they're in separate Git repositories on Linux. And this is just a little bit awkward. We don't want to change the code too much. I mean, the layer is going to be preserved. That's really nice and clean. But we want to get them on one source just for manageability reasons. This also gives us a nice opportunity to nail down what that ZFS kernel API is, right? Or portability of the other platforms. To clearly quantify what interfaces that everybody needs. How do you extract the way clean them? Plus, there's some other benefits here that I think are a little less exciting for developers, but are frankly important to make it succeed. Simpler packaging for users and maintainers. You only have one package to maintain. Everything's a lot better. On the Linux side, we've got a KMod dependency problem. We've got this, right now, because they're split into two separate modules, two separate source trees, you have to build the SPL module and install it on the system, which works fine if you build it against the kernel module. But then you need to build ZFS against it. And it turns out that the Linux build system was never really designed to build against other out-of-free kernel modules. So now you're building against another out-of-free kernel module and a Linux kernel. You have to play some tricks to make that work. If it were all in one package, it would be a lot easier to use, more reliable. A lot of problems go away. You wouldn't have mismatched versions potentially. These are all things we've addressed in the current tree, but they could be cleaned up. For developers, one source tree is nice, just convenient. Frankly, it makes all portable with other platforms. Getting everything cleaned up and well-defined, just good for the code base. 09, this is the last big thing. I think probably needs to go in before we have a one-over this. Stable API. So I know people have looked at this before, but when I talk about a stable API here, I'm talking about a user kernel interface API. I would really like that to be nailed down for Linux by the one-over release. Right now, we keep it, we try to minimize any changes to this because it's very disruptive on Linux. So one of the big problems is, at least on the Linux platform, right, when you upgrade your system, you upgrade all your user packages, and they all go forward, and you're running new versions of all user space utilities. Those versions need to work with the local kernel modules, particularly if you're using the file system. So what the API needs to be clearly defined and, only changed if we absolutely need to. So we're leaving ourselves some time here to figure out exactly what that needs to look like and get it right before one over this. Same thing true for downgrade, of course, too. Also, before one over release, I'd like to get some of the hardening done. So right now, ZFS is really, really good about this. It's really, really robust, but it could be better in certain ways. A lot of this boils down to, I think, better error handling or more rigorous error handling in ZFS code. Currently, there's an assumption that if you get a block back from disk and the checksum's good, data in the block is good. And you just operate on it unconditionally. Well, that's almost always true, but there are certain cases where it's not. And if you just trust that data blindly, it can crash. But that's pretty rare. But it's there. That's a nice thing that we like to harden. Also, better management. So this is called bulk management on Solaris and the other platforms. We started building the infrastructure for this on Linux to do better bulk management. So there's a daemon called the ZFS event daemon. It's got working. The idea is to consume events from ZFS, similar to FMA on Solaris, and then take administrative actions on it. Things like our replace will get built into this. We really want to see that in place because that's something everybody wants. So this allows us to basically run on lower end commodity hardware, right? Which we don't, on the Linux side, we don't always have control over what hardware people are running. Often it's whatever they dug out of their garage, right? And they want it to work well. So we don't always have the luxury of running on nice expensive hardware. We want to make that robust. Yeah. That use case robust too. So once we get to 1 hour, happy day, right? Looking forward to that. When we get there, basically, we're going to be in a happy place. We're going to start focusing more on development. Right now, we're just trying to get everything together to get it finished. But a nice high-quality code base we can live with long term. And when we're there, the idea is, like I was saying, the domain tag will hopefully adopt semantic versions. So, what that API and that interface is, you can count on being stable. Right? If we change the API in some way, we'll roll the major version of ZFS. So it'll know that version 2, version 3, version 4. Right? So you know that all 1.x versions are interoperable. That will be the goal. Yes, user kernel. So just to be clear, yeah, just the user kernel interface is all we really want to nail down. So I would love to work with our community on what that interface needs to look like. I mean, we're really flexible, but we need to be something that has a little long-term thought. So if we people come in, we can properly support them. So quickly, I wanted to go through the development model we use on the Linux. But that might be a little bit of interest to people. So the project's hosted at GitHub. Pretty active. We've got a lot of folks watching the project. We treat Illumos as the upstream code base. And like I said, we're independent of the Linux kernel. So this is actually really nice in a lot of ways. It decouples us from the kernel, which is pretty cool. So you can roll your kernel forward, or ZFS forward independently, or backward. So you're not stuck with a particular kernel version. Currently, we support a wide variety of kernels, a whole range of them. And this enables use on non-Linux platforms. If people wanted to go through the effort, they could, update the build system to build on that platform of choice. Some other advantages of this, utilities and the KMODs can share the same code. This wouldn't be true if we were in Linux kernel proper. We have to maintain a separate out-of-free version for all the utilities. People here truly work on the ZFS code know how much code is in common between the two of those. That would kind of be a pain. And frankly, it's easy to integrate changes from OpenZFS and everybody else is out-of-free. So, we use the issue tracker for issue reporting of the project. Feature requests, load reports, milestones, all this stuff goes in the issue tracker. It looks like we've got a lot of open issues at the moment, but bear in mind that a lot of these things are feature requests or minor bug fixes or minor issues people have reported. But basically, we encourage people to open as many issues as possible so we have an idea of what people are dealing with and what issues are hitting. So we're aware of what they are and we get the most important ones addressed. Everything's going to be open, try to be as public as possible about this. So bring your issue to the tracker, we'll work on it there. This preserves all the discussion for everybody to see. You can search it, find what's going on, if it's a known problem. It's a nice way actually to put users and developers in touch, I find, because often users won't want to post the developer mailing list, and developers might not watch the user mailing list. So getting them together in web trackers, it's a combination that seems to work well, and preserve that discussion. Plus, let us cross-link the issues that particular tracker fix and things to fix. We use milestones pretty heavily on the project. I like to use them more. So basically a way of making public what we're working on and what probably needs to be fixed. So when an extra release comes out, what's blocking it. As you can see, we're rumbling along for the 06 Explorer release, but we're not quite there yet, and some stuff has been done for subsequent releases. Like I said before, kind of working all these things in parallel. Pull requests. We use pull requests for changes against the project. So when someone wants to propose a change, they open a pull request. We review all the pull requests. Hopefully as many reviewers as possible. I'd love to get more reviewers with this sort of thing. We use continuous integration as a development model here. So when you open a pull request, the changes get automatically tested by the build file infrastructure. The changes are pulled from GitHub, built for a variety of platforms, and then you get tested results back in the pull request. This is kind of a work in progress. Like Matt was saying, I'm really interested in getting good infrastructure built for all of this, for testing and just giving feedback to people, make sure nothing bad sneaks in. So developers get quick feedback relatively when they open a pull request. Within a day or so, they should have build results. We get reasonably good test coverage at the moment. Test a lot of different kernels. I'd like to get more architecture tested. We test a fair number of distributions at the moment. But in all dimensions here, we should be expanding the test coverage. We use ZFS tests right now, which is a pretty good test coverage for things like the process layer. But we're still working on porting the ZFS test suite. So things like utilities and whatnot don't get nearly the test coverage for sure. That's a bit of a work in progress, but we absolutely want to see it tested and merged so that every time someone proposes a change, all the tests get run, right? And they immediately know if they broke something. When changes are merged, everything's the second time. We really want to keep the master branch stable. So if it breaks the master build in some non-trivial way, that change gets reverted. It'll come out until we get it right. So this whole process and GitHub in general is designed to make contributing as easy as possible. We really want to lower the bar of entry. We want to encourage people to pull requests and changes, discuss stuff there. It should be as easy as possible. Right now, Livermore acts as the gatekeeper. We merge stuff. Frankly, if you've got a pull request open and everyone agrees it's good and it passes the testing, it'll get merged. So here's an example. Just with one pull request I'm kind of excited about, but this is work that was done over the last, I don't know, I think like 3-4 months now by Prakash and then in the audience. This was integration of trace point support for Linux. So basically, we take trace probes and we wire them into Linux trace points. So we get really nice traces for ZFS. Pretty excited about this personally. I think it'll make it a lot easier to debug certain things. But the thing to note here is the pull request is on the bottom You can kind of see the yellow dots in the lower left-hand corner. Yeah. Those are the status report for the automated program. So it turns out that when this one got submitted, our testing infrastructure is down due to power work for the weekend, so they weren't tested yet, so they're still pending. Hopefully today or tomorrow, we'll get the infrastructure back online and we'll automatically test the patches there, and we'll see how they do. When they're good, they go green. If anyone test fails, they go red. Here's the output from Buildbot, or at least one view of it. So this is the current status as of Friday, I guess, for our master branch. So the thing to note here is every row is basically a commit that was merged to master. And every column is a different distribution of Linux. If it's green, everything's good. If it's red, then some tests failed. We do have a couple spurious false positives still in test suite that can cause random failures. We're working to run those down. Those happen to be what the red ones are. I think we must have turned off the infrastructure while those tests were still running. Because that just means nothing, those tests haven't run yet. But basically you can see that, for the last 4 commits, right, we've kept things in a pretty happy state. You can drill down into the buttons by clicking on it, and it'll give you, what tests were run, with the output of the logs, and what tests failed. So you can always follow along and see what's going on. So that's pretty much it. Join us. We're looking for contributors. I totally want to echo what Matt said, which is we want more people contributing, we want more people helping. Anything we can do to make that process easier, get more people involved, I think is great. If you're a developer, help us support changes to the remote security of Linux, or frankly, even better yet, help us support changes from the Linux side back to Windows. I mean, we haven't been nearly as good as we should have been about pushing stuff back upstream, right? I mean, we all know why, but it's just a lot of work. So we do track the Windows pretty closely, so we're fairly current. I think we're probably only maybe a month or two back at the moment from doing this stuff. There's some gaps in what we pull, but we're pretty close. Help us review, pull requests, comment on stuff. Let us know if we got something wrong, or if you don't like a particular feature, or you've got a better way of doing something. That'd be great. Implement something. That's great too. And like I said, help us improve the automated testing. I am a big fan of the automated testing. So any work that can be done to make that process more reliable and better, come talk to me. Make it better. I'm all for it. If you're a user, like I say, open a new issue. Let us know what's broken. We'll get it fixed. We have a really wide variety of users, so they try every conceivable thing we could imagine. And they find all the corner cases. Open pull requests, you can contribute fixes. I love seeing pull requests just for things like documentation updates. They're really wrong, right? You fix the man page, that's great, right? And help us test. Always run a master branch if you've got test machines you can afford to do that with. Let us know. It just makes us a better tag and quicker reason. So that's all I got. I don't know if there's not questions or not.
You mentioned a good thing to do would be pushing stuff from Linux back to Windows. Do you have a list of things?
I don't, but I mean, they're all over there.
Because there are a lot of things, and it's hard to tell which ones are Linux specific and which ones should go upstream.
That's true. A lot of the things are Linux specific. We do have certain things that aren't. I don't know if we've kept a real list of them. Maybe we should keep that in mind.
I think that would be helpful.
Yeah. We could certainly tag the issues that way, but I'm not sure that every patch had an issue associated with it.
I've actually done basic tests with that, and unfortunately, it's so easy. It is successful with those as long as and actually run the doors and get to be able to test it. And somehow believe it. So if you want, we could probably pair on that during the hackathon.
Yeah, if you have the diff set, that's
It's already paired to test. I just have to set it up.
So
grateful you guys have done documentation about trying to get started with building stuff. How do you test the modular test? I test that in my life system without probably the best way to do it. So it's basically sort of like a documentation guide or like people started. I think it's an question to be like what exams for doing that.
I think we should. We don't have the concrete plan. I think so. I think there's actually a lot of tricks like that for how to build source and test it. I'd love to get that posted on the webpage. Just how do you build it for Linux? How do you provide it? That'd be great. We are at the moment.
How do you, like, if somebody puts pull request, you just automatically run it?
Yeah, so there are hooks for GitHub. At the moment, it holds
So
GitHub.
my question is, like, how do you do with, like, any kind of configurations? Like, we were concerned with, like, what if somebody uses pull request that, like, in the file says, you know, find all the stuff on the network and send out over these configurations?
Yeah. So at the moment, it runs on a private network device. And also all the VMs are created pristine every time. So the new VM for pristine template will survive for the life of the testing and then they'll be destroyed. So we've gone through fairly rigorous supporting. We don't still do that. Yeah. We'd love to move some of that infrastructure out from the to if possible into the cloud. Just make it more available to people. So at the moment, the FPL is free Linux specific. We've been whittling away at it, right? Only keep the key bits that we absolutely need for portability. So getting smaller, I think. And like I say, if we want to pull it into the ZFS tree, we should have a really good idea of how big it is, right? Exactly the minimum everything we need to put it on. That number's actually going down, so I think it might not be so bad, actually. We're finding things that we'll just implement them properly or at the ZFS layer rather than the
So you gave sort of a feature timeline when the various releases of ZFS do you have any idea how long the timeline looks like?
when they're done. I wish I had dates for you, but I don't. It's just a matter of when the work is done, it's done. So the more help we can get, the better.
On the Windows systems today, the stable interface is typically a library provided by the system rather than a kernel user interface. Has there been any thought given, I don't know if they wrote this, has there been any thought given to how to resolve those priority versus different design constraints given that the Linux part is stable interface will be moved out?
So there's actually two talks later today that are going to touch on this subject, I think. So there has been some thought. I don't know if you are keen at all.
I'm only a little bit. I think it's something we actually need to talk about and nail down what works for everybody.
The same problem exists on previously because they like upgraded. They don't always include environments like those that we don't use.
There's a fair bit of testing on this on the build off, but it's not long-term stress testing, you mean to say. We do have some dedicated machines that we use to qualify the systems before we roll them out. So we'll, put the latest code on there and kick the tires, make sure that it holds together. Stress test and management, I don't know of anything automated like that. If someone does, that'd be great.
I have it set up so I can do the actual thing as in my workday with my workstation. And I'm actually doing my tasks somewhere else as my time permits. Due to some nice results on that, I can't actually make it run loops. And most of that I've actually done is but this is going back to the story evolution in some cases, or in many of the cases that have been fixed, the issues actually turn out not to be ZFS code, but in the Z-test and the waste of code, and we both use plan, and waste of code, and we use RS requirements.
Yes, I should mention, one of the other stress tests we do, at least I do, is I run it on the desktop 24/7. Right, and I've had months of uptime on it, so I care a lot when my desktop crashes, so I'm very motivated to do it. So I think it's a really good stress test. And you notice the little things too, like latency and whatnot, right, that you might not catch on automated testing. Right, if it feels slow or sluggish, you'll know if it's your desktop.
This might be a silly question, but I was thinking about actually, say, from something around schools, something like that, does the version in any way, like, do I really need to compare the version of, let's say, on Linux, if I that's a
You don't, in the sense that that version doesn't really matter. What matters is like what features are implemented in that version, so the feature flags, and those will change based on the version you're running, right, on Linux, but as long as they're supported, it'll be fine. I don't know that I understood the question exactly.
If I have issues that really bother me, I'm willing to pay money to get that things. Are there any level for it?
Well, yeah, we have done bug bounties in the past. People have posted bug bounties in the mailing list, and almost, at least the other times it came up, developers stepped forward to fix those bugs and send the bounties. That's one solution. There is no commercial entity I know of that does contract development